Okay, this is just kind of a quick introduction to what I think is important in section 13.2. Excuse me. I've got two sets of data here. And if you see here, it's kind of grouped around 8. It's not too far apart because in both of these cases, my mean is 8. So I'm looking to see how spread out I am from the mean. That's what the standard deviation does. So here, these aren't far from the mean and those aren't far from the mean. And if I calculate my standard deviation, it gives me an idea kind of the average distance each of my data points is from my mean 8. So it's not too large here. Yeah, and I use the website for that. Here, we get a standard deviation, that's an S out of 5, of 6.3. Notice it's much larger because 20 is far from 8, 1 is far from 8. So my data is much more spread out. So we're going to be talking about the normal distribution in this stats class, and that's this bell-shaped curve, where right in the middle is your mean. So what the standard deviation tells us is how close we are to the mean. So I'm going to redraw these normal distributions because this one doesn't have a very big standard deviation, meaning most of my data is clustered around the mean. So my normal distribution looks like that. This one's probably okay. Same mean, but see how it's more spread out? That's because my standard deviation is larger than that one. So in this class, we're not going to be too worried about calculating it. I'll show you the website. I just typed in these numbers and it spit this out for me. We're going to be much more concerned with what do we do with these two together. That's a big part of statistics, is the mean and standard deviation working together. And to just give you a very quick overview of where we're going with this, think of men's height. Okay, it's distributed normally. So in the middle is the mean. And I think it's kind of close to 6 feet. Maybe a little less. Well, what we do in statistics, and in this case, I'm even going to, this is the population mean. I just threw a new symbol at you. It's called mu, but it's population mean. Sorry about that. And we're going to worry about sigma, which is the population standard deviation. So it's either S or it's sigma, S for a sample, sigma for population. Sorry to spring that on you, but I kind of need those symbols for my... So what we do is we start to move away standard deviations from the mean. So I go out 2 standard deviations. And then I go 2 standard deviations out here. So this would be my mean plus 2 of my standard deviations. This would be my mean minus 2 of my standard deviations. And we do that because out here is the really unusual stuff. Statistically significant stuff happens out here. So I'm going to give you two names to look up. So out here are the really tall people. Look up Yao Ming, Google him. And over here are the short men. Google Vern Troyer. You'll see pictures of them together, and you can see what I mean about statistically significant being more than 2 standard deviations away. So we tie the mean to standard deviations, and it allows us to start doing some really interesting statistics. That's it.